Welcome back. This is the second world break question. It's actually a hard one. So not only we need to return whether it's possible, we want to return all the combinations. So we're still given a string in a dictionary of strings, word dict, and we want to add space in S to construct a sentence where each word is a valid dictionary word, and we want to return all such possible sentences in any order. Note that the same word in the dictionary may be reused multiple times in the segmentation. So let's look at one example. If the string we're given is cat, sand, and dog, or cat, sand, and dog, we have those words cat, cats, and sand and dog. We can display all the words to cats and dog, and cat, sand, and dog. The same thing for pineapple. We want to return all the possible outputs at the end. So how are we going to do that? Of course, we know that we are going to have an answer, and at the end, I'm going to return this answer. And somewhere in between, and we also know that for this question, we need to, so for example, if this is my word, and I'm at here, whoops, I'm at here. If my suffix is in the dictionary, so it's a unordered set of string. Cool. So if mine is in the string, then what I need to do is I need to recursively call this difference function where we have a mapping between a string and a vector of strings, and we want to combine this m by adding the suffix or the right word, and then we want to add everything to our answer. Okay, no problem. Let me first create this unordered map to serve as a string and a vector of string. Let me call it memo. And then here I would just call recursive with memo. And of course I should return this string. And before that, let me create a more efficient word dictionary. It's unordered set. I will just construct my set, use begin and end. Okay, cool. So let me also do answer. And yeah, okay. Now let's write this void recursive with memo, and of course we want to pass this string, and we want to pass this unordered set by reference since it will not change, and we want to pass our answer. Okay, cool. Actually, we should return a vector of string with this one, right? Okay, so if my memo.count is already there, what we need to do is we need to return this memo, and otherwise we would have vector answer, and I would have memo, this string will corresponding to answer, and I want to return answer. How can we get this answer though? Then maybe I will not need this. We will see. Okay. So what we want is first, after I claim the answer, I need to double check if my count s is already in that, then I just push back the whole string. Then I for every substring, I check the previous and the left side and the right hand side. So for every substring, check prefix and suffix. Alright, okay, so what we can do is for suffix, I guess I can do length equals to 1 and length is smaller and equal than s dot length and l plus plus, and then I can do string left is equal to sub string. I will always start from 0 and I have a L. I cannot have the whole string, so that I would, you know what, I'll always start from 1 and then I will not be equals to my length because I will not have the whole string. The whole string is already considered here. And then my right hand side would be, you know what, I will just do L equals to, yeah, I will start from L. Right is equal to substring L. Yes. Cool. Great. Okay, so for example, if I starting from 0, and then my L is starting from 1, the first character, the last character would be L minus length minus 1, right? Cool. And then if my ST does not even have this, I'll just do continue. Else it does, then I would have auto left strings will equal to, I'll just recursively call this, where my string will become my left and st, and I would have my combined as combine. I would have left strings, which is a vector of strings, and my answer and my right. So what can I do is I need to, for every possible ones, I need to insert at the end everything. I need to insert everything of my combined, and now I would need to write this combine function, which will return a vector of string. Combine. The input will be left, and I'll just have a string right, and I need to return answer, and I need to initialize my answer, and in between I would do for auto left in left, I would do push back L plus this and then plus right. Now let's check. Did I? Line 16. Oh yeah, I should just directly return this one instead of return answer. The time complexity is an issue though. Combined. Use of identifier. Should I do vector of string? undeclared identifier. Should I do it here? Because it's like a scope or stuff, right? Oops, I think it's a parameter scope thing. Okay, so the time complexity would be, the space complexity would just be how many substrings are over there, and then we have all the different. Let me look through to analysis. Honestly, I'm not sure about the time complexity and space complexity. Memorization said it will be bottom up. I'm using bottom up kind of, right? N be the length of the input string, be the number of words. In the worst case, every adjacent characters. Space complexity is also the same. Wow. Yeah, I myself need to take a detailed look at the time complexity and space complexity analysis, but I think the code works. So it's a classical example of using recursion with memorization, using the top-down dynamic approach to generate all the possible combinations. Some of the trick part is we need to abstract this combined string and make use of this recursion. So I would say this is the most tricky part. But other than that, some of the details also include, like, we need to consider the whole string first and then consider its substrings. I need to definitely grinding this question one more time and focus on the time and the space complexity analysis. But within that, I don't want to remake the video. I hope you guys enjoy the solution, and I'll see you next time.